Morning and good afternoon, everyone. Thanks for having us. So, today we're going to talk about organizational experience of building and scaling custom HR modeling software, essentially moving from a spreadsheet model to R-based ecosystem in enterprise settings. Before we start, just a quick disclosure from me. I'm an employer and shareholder of GSK, and at GSK, I'm part of the Global Health Economics Modeling team, and I'm a Health Economics Modeling lead for oncology. So next slide, please. So in this presentation, we focus both on the system architecture aspects and some of the practical organizational lessons that we've learned along the way. So why we are doing this? So we started from kind of the need to consolidate and streamline modeling approaches across therapy areas. And the tools we are talking today are tools for early stage economic modeling, where for internal value exploration and the internal value communication, where we can have the flexibility of using the modeling and communication platform. That's why we are using R across R-Shiny across the therapy areas. So we had several motivations to kind of start and expand this work, and this motivation included faster iteration of the development cycles, reproducible, transparent modeling framework, reusable and shared tools across therapy areas, and eventually integration into a secure enterprise cloud environment. So next slide, please. So, and this slide just summarized why we move in this direction and what the value we expect from this development. So HEOR modeling is no longer about single tools. It's becoming an ecosystem, and we wanted to have approaches that are scalable, consistent, and fast, with increasing expectations for transparency from our internal stakeholders and potentially externally. And in our development, we focused on iterative development as evidence evolved and on building platforms that can support multiple indications and markets, essentially creating a reusable knowledge base. And we have some important enabling factors within the company. It is acceptance and experience of code-based models internally. Rapid learning, particularly in the environment where you can learn very quickly with the support of some artificial intelligence tools. And demonstrable communication capabilities and R-Shiny interface with automated reporting and the availability of high-performance IT environment for hosting code-based applications. So next slide, please. This is just some highlights of the architecture of the internal system and the cloud-based environment within GSK. So we have already have R-based computation environment for statistical applications, and this environment was sufficient and enabling to host HEOR applications. So we have a GitHub environment, we have the development environment, and we have a deployment environment such as POSIT Connect and high-performance multiprocessor computational environment. So next slide, please. And for the deployment, the system is able to host R-Shiny applications, and we have the capability of publishing quickly iterative development of the HEOR models. And with the platforms we are working on, we are developing and we have developed a standardized workflow for development of the model, downloading of the model to our environment and deployment of the model for shared use by our stakeholders. So next slide, please. And next slide, I think, Rob, over to you for the overview of the system, your perspective on this.
Thank you very much, Yevgeniy. So I'm going to talk through some of the previous or the models that we've built over the over the last year or so, and discuss kind of the methods used for that and the implications and kind of range of projects that have been developed within GSK. So there's kind of four main platforms that we're going to discuss. The first is a chronic liver disease, so MASH model that was developed. The second, an oncology early modeling platform, which I'll go into a bit more detail on. A value communications platform in vaccines, and a communicable disease microsimulation. So kind of we've got the full range here from early disease model through to value communication tools. And we're going to talk through state transition models, partition survival models, and microsimulation models. So there's kind of a range of model structures and a range within the pipeline in terms of early through to value communication. And just for background, for those of you that aren't familiar with these platforms, generally they're built, these early modeling platforms are built out to be applied to multiple products, potentially multiple indications and multiple countries, and used to guide decision making internally. And so often these platforms need to be very flexible to different decision questions. And they also need to be very rapid because they're being used kind of iteratively, as Yevgeny said, and they're going to be adapted a lot over many years. And then and lots of questions are going to be asked of them, so they're not generally used for kind of a single submission and then left. So starting with the liver disease platform, the idea behind this platform was to be able to build out a state transition model in MASH, AOD, run this in R, and use this to inform discussions on product profile, economically justifiable price ranges, and value determinants. It's customized in GSK branding, and as Yevgeny said, we've developed a system by which Darkpeak can build the platform on our side as a development version, and then the team at GSK, including Yevgeny, can then basically create an exact copy of that for deployment. And so any changes that we make can be sort of semi-automatically updated on GSK system. No data needs to be shared with us, and data's kind of remains secure on GSK's environment. And so that's kind of the really big step change for us. These platforms have kind of all of the bells and whistles that many of the shiny apps that have been shown recently in R-HTA over the last couple of days. So they've got automated reporting via PDF output or slides. They're running the analysis live in real time, incredibly quickly. They're using things like RCPP to run in C++, and improve the runtime. And obviously they look wonderful and beautiful, as any of you that have built Shiny apps know. It's always nice to have the branding and everything on them. So in terms of extra functionality and things that are kind of the next step from more of a sort of academic type Shiny app or platform, what makes the difference to an enterprise style platform? It's things like having the database in the background, storing different scenarios that have been run, and having a lot more on the kind of infrastructure setup, so that when somebody comes in, they can see previous scenarios that have been created, and they can quickly come back to those scenarios. They can see previous settings from other users potentially, and this allows us kind of to move away from kind of a single use tool to more of an enterprise level tool that is used by multiple people over the course of many years. So this is the value communication platform, and the idea here is that users will be able to log in, reload previously run scenarios to then be able to share live with stakeholders. So they're not having to kind of select all the settings from scratch each time. They just they go in before, save all the scenarios they need so they can jump to them very quickly. Just a note on the testing side. So we developed the R model based upon an existing Excel model, and then built in automated testing to run through I think 10,000 different settings in the Excel, and then extract the Excel model results and the R results to ensure that they were identical. In a subsequent model, so a microsimulation model for HIV, we've been working through this microsimulation, built our microsimulation in R and C++, and again, scenarios being stored in a remote database. In this case, the input template was provided to allow the users from the GSK side to input multiple different countries and types of analysis they wanted to run, and then have those selected, as well as then storing new analyses they wanted to run. And an Excel template was included there as well. And potentially the most kind of advanced one from a enterprise perspective is the oncology model, which has much of the same functionality. So it's a partition survival model framework, much of the same functionality as some of the other models that we've described. But here we have a sequential flow with multiple validation steps. So users are moving through kind of a problem setup, survival inputs, selecting different curves, creating the economic model based upon those curves, and then getting the results. But really important here is that different users have different admin rights. So some types of users might be able to go in and change the recommended curve selections and define different curves as being recommended, plausible, or not available to other users. And then users from for example, a country affiliate or other users in the tool might then be able to log in and select which specific curve they want out of those that have been either recommended or been deemed plausible. And so things like that of having different user personas on the tool is really valuable from an enterprise perspective, and is something that we could probably do more to build into academic tools as well. So in terms of how this actually works, and probably the highest value add, I think, from the enterprise perspective, from GSK's perspective, is we have these different platforms, so vaccines, liver disease, communicable disease, oncology, and each one of those has a model associated with it and an interface associated with it. And what we've tried to do is to strip out a lot of the core functionality from the models themselves and insert that into packages that can be utilized across models so that we're not reinventing the wheel for every project. So we've stripped out a lot of the utility functions that might be used for modeling, survival analysis functions that might be used for modeling, partition survival model code, and microsimulation model code into separate packages that then just get called from these platforms. So if we ever make an update, say to a utility function or change some color scheme or something, we could in theory update that across all of the different platforms at once. And it's important to note that those are just kind of GSK internal packages, but all of these platforms are built utilizing open source R packages that are built by others. So we're relying on FlexServe, Quarto, ggplot, Shiny, Officer, all of the kind of standard packages that you would imagine. And then GSK has also been fantastic at allowing us to make some of the work open source, and hopefully we can continue to keep doing that. So AssertHE came about via one of these projects, and Bibi, which is still kind of ongoing but available online, has also come about from these projects as well. So yeah, a lot of credit to GSK for that. And really important to say, and I think this is probably the missing piece from a lot of the work and the incredible progress that we've seen over the last few years in R-HTA. I think the extra bit that kind of probably going on about this a lot, but the extra bit from an enterprise perspective is starting to share the packages internally, so that we've got an ecosystem of code, but also sharing a database so that we've got things like life tables, things like all previous analysis that have been run in these platforms stored somewhere, because this is going to be increasingly useful as data, as information, either for individuals within these organizations working and wanting to understand kind of the steps that have been taken to inform decisions, but also increasingly for AI tools as data is becoming increasingly valuable. So in terms of the benefits of the approach we've taken and the reasons why we've taken these approaches, and Yevgeny's touched on some of these earlier, but some of the simulations that we're building, especially the micro simulation models, are just not feasible in Excel. They just take too long to run, and often Excel just falls flat, as we know. Having a centralized platform for a given disease area really helps for rapid iteration and development and provides a location for which discussion can be had. It can be determined what the key parameters are, what the key value drivers are really early on in the process. So these early modeling platforms are really valuable. Having a consistent look and feel for those platforms is useful. So having key stakeholders within a company kind of recognize the structure and be able to navigate very quickly through a given platform because they're familiar with how it works and how it looks is really important. So we spent a lot of time on the UI UX side of things. And as I've mentioned, having that kind of memory developed via storing a lot of previous runs, previous analyses, previous settings in databases, and having some differing user roles is really valuable for this enterprise style software. And ultimately, a lot of this comes down to speed. So rapid generation of insight to inform strategy and improve access for patients. And so we're going to finish, hopefully roughly on time, providing the perspective from the developers. So the fantastic team at Dark Peak who've been working on this. And so a big shout out to them, and then also from GSK's perspective. So I guess for me to start before handing back to Yevgeny, I think the key things for us have been aligning with the infrastructure requirements of a large company, which are significant, but being flexible to their needs and really learning how to integrate into that has been interesting, but also really useful for us because a lot of the other large pharma companies have similar infrastructure requirements. So it's one of those things that we've had to do kind of once, but now we kind of understand it and we can work with different clients and help bring other clients along that process as well. And really a lot of credit to GSK for kind of working with us and collaborating and learning alongside each other as we've gone, and embracing open source solutions. So I mentioned in a message yesterday, and there was a great talk from Gabriel Rogers about the value of GitHub and working together closely. And we've kind of taken the attitude that all of our projects we make the GitHub repositories available to the client team so they can see every single line of code that's changed over the entire project, which sometimes feels a little bit exposing, but is really valuable for getting high quality outputs out. And the other thing is piloting prototypes early, so getting a minimal viable product out and working within the company to then get the feedback, recognize all the many bugs and issues that arise, and then iterating quickly to fix them and improve as we go. And just my last point is the discussion that potentially we need to have as a community about the optimal model of delivery for these types of platforms. So we've tended to find that joint development with companies has been better, partially because of data security concerns, and there's relatively few kind of software as a service provider modeling platforms. And so I'd be interested to hear where that's been successful from other people. So I'll hand over to Yevgeny and finish there.
Yeah, thanks very much. So the kind of our stakeholder company perspective has a team dimension and the technical dimension from teamwork perspective. So it's been and continued to be a great collaboration with Rob and his team. So big thanks to Rob for the collaborative style, and to a certain extent it's a joint development. The Rob's team initially helped us to build some initial knowledge in R-based modeling. It was even before the LLM, the new LLM environment. And so it's a great collaboration. From the company perspective, what is also important is important that we um, have a consistent modeling environment hosted within GSK Cloud, which is good from our perspective and from the GSK tech perspective as well. Good to have the models and the data that are by definition confidential to have completely within the company environment. And for some models, it is an early economic modeling set of applications, and some models by the nature of those models are evolving along with a clinical development program. This is a case for liver disease modeling. So it's not a model that was developed and never changed after. I think this model is continues to be developed. The situation with oncology model framework is simple. It is a partition survival model. However, we are having a growing pipeline for oncology models, and we expect to have a large database and knowledge base. We still need to think how to use this knowledge base meaningfully to maintain discussions within the internal stakeholders to help inform product decisions. And in summary, we are pioneering some of the platforms and learning from this experience, and hope this will continue in a creative and meaningful way. And again, thanks very much to Rob and his team, and thank you for your attention today.
Thank you very much. I'm chairing the session, not Dawn, but she thankfully kept me in line the last talk. But yeah, great talk. There are a couple of questions, but we are a little run for time. So I'll pass to Ben, who's got his hands up. If you two could answer in the chat, or any other questions in the chat, would be most appreciated. So I'll just do one question.
Yeah, thank you, Rob and Yevgeny, so much for that presentation. You know, that emoji where you have an exploding head, like that's how I feel right now. I have two questions, if that's okay. One is this initial investment from a company like GSK, would that mean that you are insourcing capabilities later on and relying less on vendors? And the second question is, what does that mean for like independent academic groups that are, for example, commissioned to do an independent report by NICE or HTA bodies in countries without mature HTA systems? Thank you.
And could you please repeat the first question? The second question, I believe it's for Rob, but the first question I'll try to take.
Yeah, I think you'd be perfect for the first question. Insourcing, if you're initially investing in a platform or platforms like shown here, does that mean you're insourcing some of your HTA capabilities?
Insourcing means
insourcing from vendors. Like, will you do more HTA work within GSK as compared to before?
I think historically the early economic models within GSK were developed and led by GSK modeling team. However, for complex early economic models such as liver disease, these are too big to be handled by a small team, so we are insourcing them. For oncology, most of this, the oncology early economic models was done internally based on Excel templates, was not very difficult task. But right now, I think this platform will enable us to work broadly with our internal stakeholder community using the platform. Did I answer your question?
In terms of the second question, maybe we can follow up on the chat so that this is more time, but just very briefly, I think so the focus here has been on early models, but obviously over time some of that may translate to more submission based models, and we have kind of plans underway or discussion underway around how we export out to Excel, and how and we've developed the models in such a way that they're kind of ready to be adapted rapidly to HTA. So certainly not wasted effort. The models are built to be essentially HTA ready.
Thank you very much for that.